Beak of the Finch, which was written in 1994, follows evolutionary biologists Peter and Rosemary Grant as they conduct groundbreaking research on Darwin's finches on the Galapagos Islands of Daphne Major. Through decades of close observation, the Grants gathered precise, long-term data on the finches and their population, documenting how natural selection occurs over time. The book centers around some key evolutionary forces such as mutations and natural selection. One example is in the 1977 drought, which many of the finches with smaller beaks died off, while the finches with larger beaks survived and passed on their traits to their offspring. Later chapters examine how hybridization between the finch species sometimes led to stronger and more adaptable offspring, challenging traditional views of species boundaries. The author uses Grant's works to explore broader evolutionary themes, comparing their findings to everything from bacteria evolving to resisting pesticides, to how humans influence evolutionary pressures through environmental changes. The book argues that evolution is not slow and distant, but it's actually ongoing and measurable. The Beak of the Finch proves that Darwin's theories are still relevant today and more alive than ever.
The big question the book tries to answer is, how can we observe evolution happening today? Our chapters 6, 8, and 13 help answer this because they show how evolution can happen in real time and can be observed through changes in living populations. In chapter 6, finches with larger beaks survived a drought, demonstrating natural selection within a single season. Chapter 8 reveals that hybrid finches can thrive, challenging fixed ideas about how species and showing evolution's unpredictability. Chapter 13 explores how species can blend through hybridization, providing evolution in an ongoing, observable process and not just a thing of the past.
Chapter 6 of The Beak of the Finch.
Good evening and hello to Evolution News. Tonight we will continue our coverage live from the Galapagos Islands, home of the finches. Today we'll be following the evolutionary biologist Trevor Price, who has been tracking these finches extremely closely. Closer than I track my wife when she goes shopping.
Trevor Price built on to Peter and Rosemary Grant's work by observing the survival of the birds as well as their reproduction, the second layer of natural selection. He tracked individual birds in order to find out which birds survived better, mated, produced, and visit viable offspring. Doing this allowed him to observe how both natural and sexual selection affected beak size and shape. For example, he confirmed through his research that beak size remains the same one reaching adulthood, revealing that the difference between beak shape in generations was true evolutionary change. Whoa! There goes a wild finch. Let's take it to Trevor.
Hi, I'm researcher Trevor Price. By closely tracking the gene pool, I could see that certain alleles controlling beak traits were favored based on environmental pressures. For example, after the drought in 1977, the birds with deeper and stronger beaks had higher fitness as they could crack the tougher seeds left behind, which helped them survive, just like how I'm the most fit in the gym. On the other hand, the finches with smaller beaks ended up dying due to a lack of food, which now left more finches with big beaks, becoming the new norm. What in the world? Where did those come from? Sorry for offending the finches, I'm just telling the truth. Anyways, moving on, I also observed that mate choice had a role too. Birds tended to choose mates with similar beak size, an example of non-random mating. I might just compare myself to a finch, I'm just as picky as they are.
Haha, I wish I was as picky as you are. Price's findings fit with John Endler's experiment on guppies, when he demonstrated how predators and mate choices work together to influence adaptation. The finches aren't just surviving, they're evolving through reproductive isolation mechanisms.
Chapter 8 of The Beak of the Finch.
We have now traveled from Daphne Major to the faraway lands of Princeton, where Peter and Rosemary Grant are analyzing years of data they collected.
Welcome to Princeton University.
Thank you for your warm welcome, Dr. Grant. What surprised you the most when analyzing your data?
We found that shifts in allele frequencies can occur after just a single drought, showing how strong environmental pressures are. I suppose I'm just as easily influenced as they are after meeting my wife.
To add on, we've also noticed that even birds of different species, like the common cactus finch and the medium ground finch, mated and produced hybrids. This challenges the idea that species are always reproductively isolated.
So, hybridization, or the process of mating two organisms of different species or varieties, resulting in offspring with a combination of traits from both parents, plays a larger role than many scientists expected?
Yes, similarly to Rosemary and my own children, these hybrids were fertile and successful. They introduced new genetic combinations into the population, increasing the gene pool and sometimes offering advantages in different environmental conditions.
The Grant's discoveries at Princeton highlights that speciation isn't always a simple process, but indeed very complicated. Their work demonstrated how gene flow can occur even between distinct populations, making evolutionary divergence much more complex than previously thought, just like my love life.
Chapter 13 of The Beak of the Finch.
Back to Daphne Major. Whoa, the scene has definitely changed. I fear the wind is extremely strong here. In 1982 to 83, Daphne Major was struck by one of the strongest El Nino events, or a climate pattern that involves warming of the ocean surface temperatures in the central and eastern tropical Pacific Ocean in history. The island's ecosystem was thrown into chaos, and I feel like I'm in the middle of this chaos. Let's escape this storm and talk to Peter and Rosemary Grant.
We're back to Peter and Rosemary Grant.
The El Nino devastated many of the plants that provided food for the finches. The cactus fruit, usually an important part of the diet for several finch species, nearly vanished. The island was left with mostly smaller, softer seeds because of the large hard seeds that some species needed and they were no longer available.
I would personally be devastated if my diet of junk food suddenly disappeared. As this environment changes, natural selection occurred. Birds with narrow beaks had higher fitness because they could exploit the remaining food sources. But most surprisingly, the hybrids often outperform both parent species in these new conditions. I would be elated to see my kids outperforming my wife and I.
So, the hybrids were actually better adapted than the original species?
Exactly. The hybrids had a blend of traits that gave them the flexibility in the changing environment. This demonstrates how evolution isn't a straight path. Instead, species can split apart or merge together based on their environmental conditions.
The Grant's work during the El Nino demonstrates punctuated equilibrium, or long periods of stability interrupted by sudden dramatic change. It also challenges our traditional ideas about speciation. Speciation, the gene flow between species, doesn't weaken a population, but strengthens it under environmental pressures.
The story of the Galapagos finches shows us that adaptation is dynamic, ongoing, and shaped by complex interactions between environment, genetics, and chance events like El Nino. Thank you so much for these amazing researchers, and I might as well add that I would like to be more like finches, especially when choosing mates.